Nathan, did you get it in? I hit return right when you were typing. Did it go? Oh, it didn't? See if it'll let you do it in a comment. So I was returning them right when I saw you start typing. Y'all missed some stuff on that.
Alright, solving inequality, in case my stops grade 1, it's just like solving an equation. I'm trying to isolate the k, and it's got 5 being subtracted, so I add 5 to both sides. And it just gives me a k. That's gone. The sign doesn't change in this problem, so it's still greater than 6. So k is greater than 6. Looks like it's got to be c. The number line is shaded to the right of 6. Alright, what we've got here is a linear inequality.
I did that when I was watching it this morning, but it went all the way. Let's see if it'll go all the way this way.
Alright, well, we've got here linear inequalities. I've got k minus 5 is greater than the last one, k is less than or equal to 942. Alright, solving inequality, in case k minus 5 is greater than 1, it's just like solving an equation. I'm trying to isolate the k, and it's got 5 being subtracted, so I add 5 to both sides. And it just gives me k. That's gone. The sign doesn't change in this problem, so it's still greater than 6. So k is greater than 6. Looks like it's got to be c. The number line is shaded to the right of 6.
Okay, I guess that's all we can get today. Alright, a couple of you had the sign wrong. I don't know if you just didn't see it right. And, I mean, nobody picked the 942 one at least. That was good news. Nobody picked that. So I don't know if you just didn't see the signs right or what on those. What we're looking at today, still doing inequalities a little bit, but talking about intersections and unions of sets. That's when the words and or are going to be important for us, and we'll see that as we get through this. Symbol, just give you some stuff first. Intersection. The symbol for intersection is an upside down U, and that's going to be our and word. Okay, intersections are and words. So if I were looking at this in terms of a Venn diagram, if I had my sets here, if I name these set A and B, the intersection would be the stuff that's in both of them. That would be my intersection of A and B there, right? That upside down U means intersection. That means it's got to be in both of them. Can't intersect with them if you're not on both roads. It's got to be in both of them. Okay, so for example, if I had, say this set A has the numbers in it 3, 4, 5, and 6. Set B has the numbers in it 5, 6, and 7. I'm asking you to find the intersection of A and B. That's how you would read this right here. Find the intersection of A and B. So it's got to be the numbers that are in both of them. So what numbers are in both sets? 5 and 6. So that'd be it. Intersection's got to be in both of them. Now to put this in context of what we've been doing, we're going to solve some inequalities with it. And just like we're going to be talking about intersections and unions using the word and or, our inequalities are going to also use the words and or. Okay, everybody good? here I've got x plus 3 is less than 1 and x minus 4 is greater than negative 12. So directions say to solve the compound inequality and graph the solution set. So that's pretty easy to solve. We've got two separate problems to solve on that. The one on the left, I look at it and say, well, it's got 3 being added. So to get the x all by itself, I need to undo the addition of 3. How do I undo the addition of 3? Subtraction of 3. Very good. So this one would give me x is less than negative 2. Nothing to it, right? And what would I do to isolate the x on the one on the right? Add 4, because 4 is being subtracted. That gives me x is greater than negative 8. So when I go to look at this on the number line now, remembering this was an and, meaning it's an intersection, I've got, make sure you get these in the right order, negative 8 is smaller than negative 2. You've got to remember that, right? Be surprised how many people put negative 2 on the left. This first piece here says x is less than negative 2. That means it has to be coming to the left of negative 2, right? Going that way. This one says x is greater than negative 8. That means it's got to be going to the right of negative 8. So it's looking like that. So my answer is going to be everything in between those. And then neither one of these have lines underneath them, so it'll just be parentheses. Almost every time, that's what an and graph will look like. It'll be the part in between them shaded. You can put that, remember we did interval notation, you can put that in your interval notation as well. Almost every time when it's an and, it'll be the stuff in the middle that's shaded. Because and's an intersection, it's got to be both of them, so it's got to be there in the middle. Like on that Venn diagram, the and was the stuff in the middle. Excuse me. Okay, let's look at, like I said, almost every time, right? So there's something fishy coming up. Let's look at the one that's got something fishy on it. We've got x plus 2 is greater than, hold on, I wrote down the whole wrong problem. That's the next time. Stupid. Sorry. 2x is less than or equal to 4x plus 8. And 3x is greater than or equal to negative 9. Okay, directions are the same. Solve the compound inequality and graph the solution set. So, on the left side, what would I be looking at first on the left one? 2x's. Say it again. How would I solve it? I mean, what do I need to do to start solving? Subtract 4x from both sides. Yep. That gives me 2x minus 4x is negative 2x is less than 8. Now I'm to what Devin was talking about. I'm going to have to divide by a negative 2 here. And we talked last week, when we divide by negative, what does our sign do? Flip. So this is going to give me, when I divide by negative 2, this is going to give me x is greater than, I flipped it, greater than or equal to negative 4. Okay. Just have one step on the one on the right to solve. It's being multiplied by 3, so I would divide by 3. Do I need to flip the sign? No. But it's a negative 9 over there. But the 3 was positive. I divide by positive 3. You're correct. So x is greater than or equal to negative 3. Okay. Some of you, remember I told you this was a fishy one. Some of you see why now. But let's go ahead and look at the number line for the rest of us that don't see it. Negative 4 is smaller than negative 3. Okay, it says on this that x is greater than negative 4, which would be going like that, right? And x is greater than negative 3, which would be going like that. So it's not the part in the middle. So I didn't color completely in. I was just trying to give you an idea. If I got to be both of these, if I've got to be greater than negative 4 and greater than negative 3, can I be in here? No, because I wouldn't be greater than negative 3 if I'm in there, would I? So that part just gets left out. To satisfy this to be greater than negative 4 and greater than negative 3, it can only be that stuff. And then what kind of mark would get on negative 3? Say it again. Bracket is correct. Now, aren't as many of those types of problems, but wanted to show you an exception to what I said earlier. I said almost all the time an and is in between. There's an instance where it's not. It went on to infinity. Okay, now, before we move on to unions and ors, there is one more weird kind of and. So you ready for that? We have the normal kind to start with, where it's the stuff shaded in the middle. That's what the majority of them will be like. And we had this weird one that we just looked at, where it went to infinity. Now the last type of weird one here says x plus 2 is greater than 3, and 2x plus 1 is less than negative 3. Directions are the same, solve and graph. Alright, surely you got the one on the left solved just by looking at it. Should just subtract your 2 on that, and you got x is greater than 1. Alright, got a two-stepper on the one on the right. What would my first step be? Subtract the 1. So 2x is less than negative 4. Then what? Divide by 2, and x is less than negative 2. Okay, so I'm looking at x is greater than 1, and x is less than negative 2. Okay, so if I go to look at that on a number line, negative 2 would be to the left, and 1 would be to the right. This piece says x is greater than 1. So I'd be looking at going to the right of 1, right? This one says x is less than negative 2, so I'd be looking at going to the left of negative 2. Now, the word is the important thing here. I was told this is an and. So that means I'm looking for the numbers that are greater than negative 1 and less than negative 2. Do I have a number that is over here and over here? It's impossible, right? It can't be on both of these. So all because of that word and, that one has no solution. There are no numbers that are greater than 1 and less than negative 2. Now we're fixing to move to unions and ors. That one would be a beautiful or. But as an intersection, you can't be smaller than negative 2 and greater than positive 1. It's impossible. Everybody see that? You know, it's all because of that and. Remember I told you and or are important. It's too big.
I really like the no solution sign because I feel like I can do something like if I was a teacher, I could do something back there and go to make
Kind of harsh.
Yeah. Kind of, I'm not nice anymore.
Get that up.
Yeah.
Pick that back habit.
Yeah.
Alright, union. Symbol for union. If intersection, union doesn't have multiple I's in there. If intersection, U-N-I-O-N. Intersection's an upside down U. Union is a normal U. Okay? And that goes with the word or. So, if I go back to my Venn diagram thought that we did with the ands, if I had set A and set B there, union would be all of it. That would be the union. It'd be everything that you had there. Okay? So if I told you that set A had the numbers, do the same one we did earlier, 3, 4, 5, and 6. And set B had the numbers 5, 6, and 7. I wanted to know what is the union of set A and B. The union of set A and B. Okay? So what I'm looking for now, if it's in either one of them, it's part of the union. So, is 3 part of the union? Yeah, because there it is. Is 4 part of the union? Yep, there it is. Is 5 part of the union?
Yes.
Yep. What about 6?
Yes.
Yep. Is there anything I missed?
7.
7's over here. It's part of the union. So if it's a union or an or, and it's in either one of them, it's part of the union. Ors are very generous. They let everybody in because you could be either or. You know, if I say you have to be in first period and Algebra 3, that could only be you. But if I said you can be in first period or Algebra 3, that's everybody at the school because everybody's got a first period. See how that's the difference in the wording there? At least I hope everybody's got a first period. People get to sleep in that I don't know about. We'll crack down on that.
My cousin has a setup that her college class.
We're not going to have it today. I don't even know what that's called right off the top of my head. Sure. I think so. It would have to be like a separate one like that. You know, call your C part over there or something. Yeah. What were you saying over there, Phillips?
My cousin has college classes and she doesn't start hers until like 1:30. She gets done at 5.
Yeah, when I was in college in the dark ages when dinosaurs roamed the earth, I was the opposite. I had all mine 8 and I was done by lunch. That's what I like.
She likes sleeping in.
No. I like having the whole afternoon to go hiking and fishing and all that stuff.
She stays in her room, plays Pokemon, and watches weird anime stuff.
Alright, so let's look at some of these with inequalities now. If I have x minus 1 is greater than 2, or, going to the ors now, 3x plus 5 is less than 2x plus 6. Okay, got an easy one on the left and an extra step there on the right. On the left, all you got to do is what? Add your 1. So that one's a one stepper there. X is greater than 3. Or, yeah, that's a 5 there, Caleb, I'm sorry. Alright, what would we do here on this one? Tell me what you'd like to do first. Say it again. Subtract the 5 Devin said. So it gets me 3x is less than 2x plus 1. Now Devin's got to do what I would have done first, which would be subtract the 2x. So that gets me 1x is less than 1. Okay, so on our number line, 1 is smaller than 3, so 1 needs to go on the left. Say that again. You're going crazy. I didn't multiply or divide by a negative. Alright, so 1, it says, well, let me go over here first. X is greater than 3. Greater than 3 goes to the right of 3, so I'm looking at going that direction. This piece says X is less than 1, so I'm looking at going this direction. Now this is an or, okay? So can I be over here on the right and be greater than 3 or be less than 1? Is that possible? Because of the word or, yes it is. So my number line I'm going to graph like that. You got a varmint or something way I'm looking for? I don't know. What kind of marks go on my 1 and 3? Parentheses, good. Alright. All because that was an or. Now, if it were an and, we couldn't be both of those, so that's when we would be no solution. But an or is good. Okay, now we've got a funny new way of writing our answer on this. So when we go to our answer, this goes to negative infinity, right? To 1. That's that piece. Union with 3 to infinity. That's that piece. So you put your 2 pieces, and when it's an or, you put your union sign in between. Kind of looks fancy. I like that. Now, on your or graphs, most of the time, this is what they're going to look like. It's going to be shading in opposite directions. And I said most of the time it's in the middle. An or, most of the time they go away from each other in opposite directions. Okay, make you a note or a mental note about that. Because now, of course, we're going to look at some of the weird ones. Okay, everybody good? Here we got 3x minus 2 is less than or equal to 13, or x plus 5 is less than or equal to 7. Alright, so what do I do first on the one on the left? 3x plus 2 is less than or equal to 13. Add 2. So that gets me 3x is less than or equal to 15, which means x is less than or equal to 5. Or, what do I do on the right? Subtract 5. Easy one to solve. X is less than or equal to 2. Now remember on that last one, I told you most of the time the graphs will go opposite directions. This is a weird one that we've got here. If I go to my number line, 2 is smaller than 5, so 2 will go on the right. This says x is less than or equal to 5, so less than 5 starts to the left. This one says x is less than or equal to 2, so less than 2 starts to the left. Alright, now when we had one like this with our and a little bit ago, and on our and, it had to be what satisfied both of them. What was less than 2 and less than 5, it would only be from here over, right? But this one doesn't say and, this is or. So could I be, like for example 4, because 4 is less than 5. Could I be 4 and be less than 5 or less than 2? Yes, because the or word. So when it's or, it's the bigger section of that gets graphed. So we will graph everything there, within, we need a bracket on our 5. So that would go from negative infinity to 5. Alright, so when they go the same direction like that, and it's an and, you always graph the least part of it. When it's an or, you graph the biggest chunk of it. That make a little bit of sense? Alright, got one more weird one on the or, and then we'll put some of them together and let you see how you do. This one says 3x minus 2, starting off the same, isn't it? Less than or equal to 13. Or x plus 5 is greater than or equal to 7. Alright. So shouldn't take you long to the only thing that to solve them, because the only thing that's different is one of the signs. These are the same numbers as the last problem. On that first one, we added 2 last time. Got us 3x is less than or equal to 15. Then we divide it by 3. It's the same as last time. That's x is less than or equal to 5. Or, the only thing that's different on this one is we changed the way the sign flips. We're still going to subtract that 5. X is greater than or equal to 2. Do what? This sign was different, wasn't it? I meant for it to be.
Oh,
Okay, good. I was hoping I didn't mess up. Alright, so we got 2 would be to the right of 5. Alright, x is less than or equal to 5, so less than's coming this way. Greater than or equal to 2, so greater than's going that way. Now, if this had been an and, that'd be it. We'd shade that in between part. But since it's an or, do I have to stop at these numbers? Can I be less than or equal to 5 way over here, or greater than or equal to 2 way over here? Yep. So this is a case where the whole shebang gets shaded, which means we would go from negative infinity to infinity. Now, notice the difference. Don't get confused, and I'm going to try to give you some to differentiate here in a minute. But the difference is the word. If that had been an and, it had only been that chunk in the middle shaded, right? You with that? Alright, let me give you some to try and see if you can get them now. Find some of the normal ones. Alright. Number 1 here. Says x minus 3 is less than or equal to 6. And x plus 2 is greater than or equal to 7. Okay.
Coach Wright,
Yes, sir.
can you pick up a second?
Yep. Hello? Hey. Yeah. I'm looking to see here. Yes. No. That's a white. Yes. That was one of the mistakes that I. Yeah. And then that we're going to go again. 7th grader going to Fountain Lake Saturday. Yes. Man, we're going to be traveling a lot that week. Fountain Lake. Yeah. Okay, sounds good. It'll just be 15 on those Saturdays, just the 7th graders. Yeah, the other ones will be 40 something, 45. Okay. All right, thank you. All right, did y'all get them solved already? Add your 3 here. It's me, x is less than or equal to 9. This one, subtract your 2. Oh, I was giving you another one. That's why y'all were waiting. We'll do the other one in a second. X is greater than or equal to 5. Sorry, Coach Mooney distracted me. Could have had this one already anyway. Alright, so less than or equal to 9 would be coming to the right of 9. Greater than or equal to 5 would be going to the, I said that wrong, less than 9 is to the left. Greater than 5 is to the right. Alright, so my question is now, do I restrict that to just the part in the middle? Or can I go, like on that last one we did, can I go forever in both directions? Just the middle. Why? Because it's an and, so it has to satisfy both, so it's only that part in the middle. Those both get a bracket. 5 to 9. If it's 9 to 5, we could sing a Dolly Parton song. That's fun. Alright, I was about to give you an or one when the phone rings, so let's do an or one to try on your own. Let's see here. Oh. That one looks good. 3x is less than x plus 12. Or x plus 1 is greater than 10. Alright, try that one on your own. Go. We got it? Alright, always a little weird when, like on the one on the left, when you're subtracting your x's first, but that's what you should have done there, was subtract that 1x from both sides. That gets you 2x less than 12, so then what did you do? Good, Sydney, divided by 2, so you got x is less than 6. Easy one over on the right, or just subtract that 1, so you got x is greater than 9. Feel like you can get all that. You can get the number line part 2, just be careful on your shading and don't get confused. 6 is smaller than 9, so 6 will go on the left side of 9. Less than 6, go to the left. Greater than 9, go to the right. I told you most of the time your oars are going to be shaded in opposite directions. That's true here, so go ahead and fill that in. What kind of marks go on my 6 and 9? Parentheses, good. Alright, Valentina's getting my interval notation. This piece goes from negative infinity to 6. Union with, this piece goes from 9 to infinity. That'd be it.
And they have to be in that order.
Yeah, I think it just wouldn't make sense if they weren't, because you're reading it like you would read the number line.
Okay.
Alright, what we go to tomorrow is absolute values. So looking at absolute values, and then that'll be it. We'll start doing some reviewing type stuff. Okay, test will be sometime middle of next week though. Still got a little bit before we get to a test again. Middle of next week sometime. Nice job.